Hey guys, we're doing analyzing graphs of quadratic functions. So it says for each quadratic function, find the indicated information. So first of all, they give us a quadratic, see the square? And it's in standard form, okay? So standard form is going to look like this. Okay, and so we know it's quadratic because that's the degree of the polynomial. In other words, that's the highest exponent. And notice it tells us if there's a stretch or compression. There's our a value. Okay, so notice there is no stretch or compression on this graph compared to the parent. So there's your stretch or compression. And here, this value here tells us the y-intercept. So the y-intercept is 3. So right off the bat, we know that 0, when x is 0, y is 3, because that represents the y-intercept right there. The y-intercept is the constant on the end when you're in standard form. Okay, now it's asking us for the vertex. So what we're going to do here is I'm going to show you how to get the vertex from this equation on your calculator. In the future, I'm going to show you how to do it algebraically. So to get it on your calculator, we're going to go to y equals, we're going to plug it in, and we're going to do second trace. And we know that the vertex is going to be a minimum because it's opening up. Okay, we know that this parabola opens up because the a value is positive. Okay, so this opens up. So that makes the vertex a minimum. It's at the bottom. So we're going to choose minimum. Okay, there it is. Okay, now it says left bound, so remember we need to go to the left of the vertex, enter. Go to the right of the vertex, enter, enter. So our minimum, aka vertex, is -2, -1. All right, so we found another point, -2, -1. So plotting that point, that would be, whoopsie, -2, -1. I'd use a pencil if I had one, but I borrow them out, and then the ones in my desk are broken. The lead is broken. So anyway, I would have erased that mark there. So ignore that little mark. So -2, -1. So axis of symmetry, let's draw that in right now. We're kind of piecing this puzzle together. Remember, your axis of symmetry goes right through the vertex, cuts the parabola directly in half. And the equation of that line is x equals -2. Notice how it goes through -2 on the x-axis. And remember, vertical lines always start with x, and they have an undefined slope. And it says max or min value. So the min value, it's a minimum. Remember, it's opening up. The min value is going to be the y-coordinate of your vertex. So it's going to be -1, your min value, because it's a minimum, is going to be the y-coordinate of your vertex. Okay? Before we get to this, let's get some more points here. So we haven't had to do any algebra yet, no plugging numbers in yet, and we still can get another point here. So this is 2 units to the right, so there's going to be another point 2 units to the left. Okay? Now, let's see, it's asking us, that's going to be 1, 2, 3, -4, 2, 3, -4, +3. I could put that here, but I think we want to go with -1, +1, and +2. I don't know, I kind of like to keep order in my table instead of putting points just anywhere. So let's do -1 really quick. -1 squared, 1, plus -1 times 4, -4 plus 3. So that's going to be -3 plus 3, 0. So we have a point at -1, 0. And then we're going to have a point on the other side of the axis of symmetry at 1, 2, 3 at -3, 0. I think we have enough points here to make our graph halfway decent. Okay, so here's our y-intercept. What are these 2 points called? Bingo, x-intercepts, right? So you see this word here, roots? That's what that means. The roots are the x-intercepts of the graph. Well, that was a nice surprise. One of my students who left came to visit me just now, so I'm back. So where were we? Yes, the roots is just another name for the x-intercepts. And another word might be zeros. So know that those 3 are synonymous, okay? Now, let's go to the domain and the range. So the domain is going to be your x values. You should be able to do this, but we'll go through it again. Left to right, so -infinity on the left. Okay, on the right side of the graph, we have another arrow, and so that's going to be +infinity because it's going to the right, and to the right is positive, and going to the left is negative. And we always go least to greatest. Okay, we use parentheses because we can never get to infinity, so we can't include it. If we're going to include a number, we have to put brackets. Now, set notation, of course, we're going to do set notation. So x is going to be an element of all real numbers, since that's what we're talking about here, every single number. All right, range, lowest to highest. So our lowest point on the graph is here. The y value is -1. And we're going to include it. So we're going to put a bracket. The highest value is an arrow. Remember what arrows mean? That's right, infinity. And we can never reach it. Going to set notation. Y is an element of all real numbers such that, and we're going to go from -1 and we're going to get bigger. So y is going to be greater than or equal to -1. This number and this number should be the same. And if the y values are getting bigger, we're going to use the greater than symbol. Okay? Now this next one, number 2, you know, this first one was standard form, okay? Standard form. This one is actually called vertex form. So there's one thing I want to hit here on vertex form. Vertex form is called vertex form for a reason. It gives us, anybody? Anybody? That's right. It gives us the vertex. Okay, and the vertex is going to be h, comma, k. Huh? Remember on the word wall that we have it in class? We have this equation up on the board. Ah, that's where the h and k come from. That's right. So the h value in this case is 2. And the k value in this case is 0, right? There is no number there. So 0. So the vertex of this is going to be 2, 0. So let's plot it. How you doing tonight, Jose? Are you awake? Are you even watching my video, Mr. Silva? Okay. Now, our A value. Let me remind you, so that we don't get too handicapped on our calculator, that to apply the A value to the graph, we go over 1 unit, okay? And then we go 3 units. It's positive 3, so we go 3 units up. 1, 2, 3. Now we know what quadratic makes a parabola, so we're going to have 1 on the other side as well. So we're going to go 1 on the other side, and 1, 2, 3. And really, you only need 3 points to make a parabola. Remember, you need 2 points to make a line? Well, you need 3 points to make a parabola. Okay? Let me see if there's anything else. You can do this. You can do this. This domain and range. Now here, since it only touches the x-axis in one place, we call this a double root, which means it's the same root twice. Okay? So we're going to use this coordinate 2, 0 as our root, which is also our vertex. And I just thought of something. We never did state our roots up here. Our roots up here are -1, 0 and 1, 2, 3, -3, 0. Almost forgot. Let's take a look at the next one. Now, notice this one looks a little bit different. This is also quadratic, but where's the 2? Where's the square? It's right here. Well, remember that when you multiply two binomials, you multiply the first terms. So we multiply x times x. Remember FOIL? X times x, first, outer, inner, last. X times x is x squared. So this is quadratic, okay? And this form is called factor form. Factor form. Factored form. And what is special about this form? Well, it doesn't give us the vertex. It doesn't give us the y-intercept, but it gives us the roots, okay? The roots. And the roots are located right here. Those are the roots. So one of the roots is 2, 0. Remember the opposite? This is actually 2 units to the right. So that would be 1, 2. It's kind of weird. And then this one is 2 units to the left. So 1, 2. So 2, 0 and -2, 0. Now, in case you don't believe me, let's take a look on the calculator real quick. Okay, so I plugged it in to y equals, and I graphed it. And you can see with your very own eyes that we have one root at 2, 0, and we have the other root at -2, 0. So what I want you guys to do for tomorrow is I want you to try to fill in all the information that I did not. If you can, get as much of it as you can. I hope you guys are having a great evening, and I'll see you in class.